Blinking means will explode.
That's cool.
I don't
I'm
think
good.
blinking's right. Let me go check with Tobias.
Okay, should I wait? Or
Yeah.
I'm like done waiting.
Nobody take my chair.
Okay, so hands up on folks who need a review of Pester syntax. Oh, really? Oh, so this is cool. So how many people who are already using Pester need a review of Pester syntax? Okay. Yeah. You know, so this is, I guess, off the record because we're not recording yet. But I approached it the wrong way. And I hope that you learned from my experience to approach it maybe the right way. What I did when I first started learning Pester was that I delved deep into the syntax, right? And I tried to figure out what was going on under the covers, under Pester's special domain-specific language. And I tried to figure out what was a function that was exported and what was a private function, and were these things really operators, what was going on with the containers. And what I learned was that it's best to forget about the actual syntax. Ooh.
I got help.
And just go with Pester's language.
What resolution you need?
I don't know.
So it means it's not happy.
Oh.
You're making it unhappy.
I'll go and see if I can find one of the technicians for you.
I couldn't find Tobias.
Okay. It seems to be working. So is the question whether it's recording?
He's saying he thinks the resolution's too high, so it might not be recording. Is the issue.
Oh. Well, we only have an hour. I'm going to start. Is that okay? I'm going to make an executive decision here. I'm going to make an assertion. We're going to learn about assertions. So I will assert that it should be started. So welcome to real-world test-driven development with Pester. My name is June Blender. I'm a technology evangelist at Sapient Technologies in beautiful Napa, California.
You should be okay, just keep.
Cool.
Should be cool.
Thank you. I spent a different lifetime on the Windows PowerShell team writing the help that you see when you type get help in PowerShell Core for PowerShell 1 through 3. And this year, I'm a Windows PowerShell MVP. So, yeah, isn't that cool? That's a great honor. So this talk is real-world test-driven development with Pester, which is really different than test-driven development with Pester, right? Because in that class, they have this authoritative view of how you should use Pester. But over here, in real-world test-driven development with Pester, I'm going to talk about my experience learning Pester in real life. And what I hope that this will help you to do is it will help you to learn Pester, right? It will give you a sense of the places where you might trip up and how to get over those. And if you're teaching Pester, this will give you a sense of what the pedagogical process is like so that your teaching process can be more tailored to the actual learning experience. Okay. These are the versions of Windows and Windows PowerShell and Pester that the slides and code were tested on. We now have side-by-side versioning in PowerShell 5.0 and multiple versions on PowerShell Gallery. So I always make note of the version. So if somebody comes back to this later, you can be assured that this matches Pester 3.4.0. Okay? When I started putting together this talk, it was Pester 2. And they're just about ready to release Pester 4. Okay? But this one is 3.4.0. And I actually recommend that people who blog put information like this on their blog, right? If you're doing a video, put a slide like this in your video. If you've got a presentation, especially if you're sharing it on GitHub or somewhere else, let people know which versions you're talking about because you might be saving them some time if the version is sort of outdated. Okay, so this was my original why test slide. And I am here going to declare that this question is moot and final, okay? We test for the same reasons that we script. We invest time up front because we know that it's much easier to prevent a problem than to clean up after one.
We do have a problem, so can I interrupt for
Yes.
a second? Amanda,
Yeah?
can you emergency videotaping Jeffrey over there?
Okay.
That would be great. You can also come back here once the camera's over there. I'm sorry.
That's fine.
Thank you very much.
I'm totally good. Great. So if we wanted to test in previous years, we couldn't, or we couldn't do it in any efficient way. And then along came Pester. And I'm incredibly grateful for a framework like this in PowerShell. The folks who put together Pester, and it was an open source project that was later adopted by Microsoft, really knew what they were doing. They didn't create it from scratch in some non-standard way. These were people who knew about code testing, and they implemented Pester and its domain-specific language, its natural testing language, in ways that were consistent with established standards in the industry. Pester was actually based on RSpec for Ruby, but if you go to another language or another platform, the concepts and the language that you learn here will carry over to the other language. And if people come from other languages and start doing PowerShell, Pester, aside from little syntax issues, should be very familiar to them. So instead of coming up with something that was sort of, just put together, they actually made a very smart decision to take advantage of decades of work in code testing and built us a really beautiful and professional quality platform. Now you'll notice it says over here that Pester is a PowerShell BDD style testing framework. So let's figure out what that means. So it all started with test-driven development around 1999. Now code testing is probably as old as code, or maybe as old as the first bug, right? But test-driven development was introduced by a guy named Kent Beck in 1999, and my reference slide has a reference to his book, which I read. The most recent version is 2003, and it's very comprehensible. This was very radical for its time, and the idea is still somewhat radical now, but it's very well accepted. Okay, this is the way you're supposed to do it. So the theory is that you write the test before you write the code. You write only enough code to pass the test. Once you've passed, you can refactor the code, test it again. If it passes, you write another test. So your test becomes your code spec. And the theory is that the code is simpler because you're only writing enough code to pass the test. The tests are all a priori tested. The code is all a priori tested in advance, and developers are not afraid to change the code because any side effects or regression bugs are caught by the tests. And in fact, I found this on Twitter yesterday. Okay, Bo Prox, PowerShell MVP, wants to refactor his code, and Doug Fink, another PowerShell MVP, said you can do it fearlessly. Okay? Behavior-driven development derived from test-driven development just a few years later. And the theory here is that you still write your tests before your code, but the tests that you write describe the behavior of the code, not its implementation, right? So you can change the implementation entirely, and just so you don't change the behavior, the tests still pass, okay? The tests are also supposed to be independent of the local environment, so independent of my database, my file system, any input that I have, any artifacts that are in my environment. And the code tests are isolated. So the test for one commandlet or function is independent of tests for other commandlets. So if one commandlet screws up, it should not prevent the other commandlets from passing their tests. And I'll show you exactly how that's done. It should cover all features. That's called code coverage. And you maintain your test code like you do production code, no spaghetti code. It should be readable and maintainable. You save it. It is your insurance against breaking. Okay? So that's about as far as I got about 6 months ago. Okay? And then I was all ready to use Pester. I learned the syntax. I learned the rules. And then I realized that I didn't know which test to write, okay? Where do I go from here? What parts of my code do I test, right? I certainly don't want to write tests that are so easy that it's almost a tautology that they'll pass, right? I needed some guidance. I didn't know where to start. So being me, I started with my help file. Okay? The examples in your help file are your behavioral contract with the user. And they state actual and expected values. Okay? So if you start with your help file, you base your tests on your help example. So the help examples are your test spec, and your tests are your code spec. Okay? That supports this theory of behavior-driven development, and there's a feedback loop, which means that you have better tests and better code. So this is what I started to do. So the little example that I used came from a whole bunch of pieces of code that are distributed throughout my file system in my .scripts file, right, my .scripts directory. So I use Windows PowerShell Profiles. I have a bunch of things in there that like PS default parameter values, things like that, that I use frequently, but I never want them around when I'm testing code that I share. Because I never want anything in my personal profile that might not be in someone else's environment for my code to be dependent on those elements, right? And it can happen. It's happened before. So I have little scripts and functions all over the place to disable and re-enable my profiles. And I decided to put those together in a module that can be maintained. And I thought this was going to be a really simple example. Okay? So I started with my help file. I used my help examples as my test spec. I created a module for my help file, and I created tests for every example. And let me show you how I did that. Okay. So this is PowerShell Help Writer. This is my favorite thing. Okay. So I wrote this help file before I wrote any code. Right? If I already had the code, this would go out, slurp up my code, and create a help file for me with everything in it except descriptions. Right? It converts comment-based help to XML-based help. But in this case, I wrote the help file first. Okay? And I actually had to make some decisions about the behavioral contract in advance. Okay? Then this is PowerShell Studio, and I did File, New module from help file. Can you guys see that? Is that big enough? Cool. I chose my help file, saved it, and it created the module for me. Okay? And it's just speccing out my functions, the functions that I defined in that help file. It adds an export module member statement, and it creates a module manifest. So that was my starting point. Let me close that. Okay, let's go back to our slides for just a sec. And we're going to go through the little syntax review, okay? So again, I learned the syntax and then sort of had to forget it. If you're learning Pester from scratch, don't do that. Go with Pester's natural domain-specific, and here we don't mean computing domains, we mean the domain of code testing, right? Its domain-specific language is a natural language for testing code. So just forget the innards, okay? So we'll begin with describe, which is a container. If you look at the upper right-hand corner, you'll see a sort of a breadcrumb trail that shows the relationship of the elements to each other, okay? So describe is a container. It is required for tests. It encloses tests. It has a name. Its name is required and arbitrary. So I think of describe as my naming container, okay? All of the containers have names, but when you use the test name parameter of Invoke Pester, it refers to the name only of the describe block. When you use the tag parameter of Invoke Pester, it only looks at the tag on the describe block. Okay, so describe is my naming container. So let me look at the syntax here a little bit. Again, this name string, it's a positional parameter. It's required. And over here, you'll notice that the curly brace of the required script block is on the same line as the name of the describe function. This is not style. Okay? In Pester, this is required because this script block is the value of a positional parameter. Okay? If you put it on the next line, then you need to include some ugly thing like a backtick. Right? And if you don't put it here, then Pester can't find it, right? It's on the next line. It's not part of this command. And it will give you this lovely error message that said, did you put your curly brace on the wrong line? Okay? That's a really well-written error message. I'm a big fan of that one. Okay? If you accidentally omit the mandatory string, again, a positional parameter, PowerShell's loosely typed system will convert your script block to a string and say, I can't find the script block. Okay? So the name is arbitrary, but it's required. Are we good? Cool. Okay. The next thing is context, which is a container inside of describe. It's an optional container, and it encloses tests. And I call it the mocking container because it's the smallest container that creates a mocking scope. There are smaller containers, but they do not contain a mock, and we'll talk about that in detail. The name, again, is required and arbitrary. Feels like it's containers inside little Russian dolls or something. Okay, it is the real test container. It's the smallest container in Pester, and it really does enclose tests. It's required, its name is required, and arbitrary. It does not create a mock scope, and we'll, again, get to that soon. Should. Should is not a container. Should is the tiny beating heart of a Pester test. Okay? This is the assertion that compares actual to expected values. So you pipe the actual value to should, and you use a B operator on the other side, a comparison operator, to tell it how to compare the actual to expected values. Okay? And the way you use this, again, is to pipe the actual value to should, and should will use the comparison operator to compare the value that it gets through the pipeline to the expected value. Cool? So far, so good. Okay. B, to be or not to be, are the comparison operators. And these, even though they have different names, mirror the comparison operators in Windows PowerShell, sometimes for better and for worse, and we'll talk about that. But these are very much like the comparison operators that you're used to. The like ones take wildcard characters. Exactly, the exactly ones are case sensitive. As a little difference, all of the contain operators refer only to files, right? You can't give it an array and say, does it contain? Oh, and the list changes. The Pester is a continually developing product, so this list of comparison operators might change. Keep your eyes out in different versions. So mock is super cool. It lets you write tests that are independent of your local environment and those unit tests that isolate code, because it replaces the output of a commandlet call with values that you specify. Okay? So when you mock something, the mocked commandlet doesn't run, and instead, Pester returns to the next thing in the pipeline the value that you specify. Okay? So you never want to mock the commandlet that you're testing, because it won't run. You want to mock a commandlet that provides input to the commandlet that you're testing. Okay? And you'll see it in my code, that I ended up writing a bunch of helper functions that provide input to my commandlets just for the purpose of mocking them. Right? So writing tests changes the way I code. Right? It becomes much more modularized. So in this little snippet, new user is the commandlet that we're actually testing. It calls get user type, and it gets some sort of a string. Okay? So I'm going to mock get user type. I'm not going to mock new user. I'm going to mock get user type. It won't run. So when new user calls get user type, no matter what else happens, it won't run, and it will return the string admin. Okay? And then I'm going to test what happens when new user gets an admin string. So what this lets me do is to test my functions with a whole variety of input that may not exist in my database or in my environment, but that might exist in someone else's, and I want to test for it, right? Now, often the way I test for this outside of Pester is to comment out code and put in funny things, right? But I have run into the situation where I commented out code, got distracted, forgot that I commented out the code, and now I've got a broken script or function. So this allows you to test with input that might not exist just by mocking. And again, I can't say this too many times, it is not a mocking scope, okay? The mocks in this it block affect this it block too. Context is the smallest mocking scope. Okay? So I use those optional context blocks just to scope my ifs, or just to scope my mocks, so that the mocks don't affect anything else. Is that kind of clear? And you'll see it in the code. I think it will make more sense. Okay, the last element is TestDrive, and this is really cool. This is something you could have done for yourself, but Pester does it for you and makes it really quick and efficient. So Pester lets you test independent of things actually on your drive. It creates a PS drive in your temp directory, okay? Every time you enter one of those describe blocks, you get a brand new clean test drive. You can create files in there, get files, write to the files, do whatever you want. You leave that describe block, Pester blows away that PS drive and creates a brand new one for you when you enter the next describe block, okay? It's scoped so that if you have a container inside of describe, right, it can read and write to the parent files. If it creates files, when it leaves the scope, any files that it creates are deleted, right? They don't go to the parent scope. But any changes that they make remain in, changes to files created in the parent scope remain there. Pester does not do a rollback or snapshot, okay? Yeah, you can create files. It's your file system, but it's just a PS drive in your current user temp directory.
Can you also use it to, for example, do PS drive to AD or the registry?
I don't want to answer that because I don't know. I think it's just using a file system. Okay, whether it can use other providers, does anyone know? I don't think so. Yeah, but let's keep that one in abeyance, and we'll try to answer it afterward. So the way that you refer to test drive is either test drive : like you do C:, okay? And also, Pester creates an automatic variable called test drive that holds the actual path to the current test drive file. So you can refer to it. You'll see that I use it for join path to create paths. Okay, we did that. The last thing is in module scope. It's used only when you're testing a module, and it's an Uber container. Right? It goes outside of the describe block, and it contains even the describe block. And it makes all of the resources in the module available to your test, okay? And even when they're not exported. Otherwise, you couldn't do things like mock helper functions that aren't exported. And this allows you to do it, okay? And then there's Invoke Pester. Pester tests are all .tests.ps1 files. They're scripts. So you can run them the way you normally run a script, you know, in an editor, at the command line, whatever. But you can also run Invoke Pester. You give it a path, and it goes recursively by default through all of the files in the path and runs all of its tests. And it identifies which files are tests by the .test.ps1 file name extension. Okay? It also has a bunch of fantastic parameters which allow you to select and write output. Its default output uses RightHost, so it does not create anything in standard output in the output stream, but you can make it do that. Okay, so we're done with this. Let's go look at some code, she says. Cool. Can you guys see that? Bigger, smaller? Is it good? Okay. So I started with that sort of blank, mocked up module. So my functions are mocked up, but there's nothing inside them. I shouldn't use the word mock in that way. So my functions are I have skeleton functions with nothing inside them. And here's my test file. Okay. So I'm just going to walk you through line by line in the code. Okay. When I create a .test file that matches my module file, there is nothing magic that associates those two. The same base name, or even being in the same directory, does not associate them. You have to explicitly associate your test file with the code that you're testing. So that first line of code, that get module, remove module, is there because Pester cannot handle multiple versions of the module in the same session at the same time, quite reasonably, right? So the first thing you do is use get module, remove module to remove any versions that are already in the session, right? And then I use import module. There are a bunch of different ways to do this. I use import module with a required version parameter to make sure I'm getting the version that I want, and error action stop so that it doesn't continue if it can't find that version of the module that I want to test, okay? If your module is in a state where you don't have it in a PS module path yet, you could just provide the fully qualified path to the module manifest, right? That's what's shown in that commented outline, okay? Here's my in-module scope. The name of in-module scope is required, but it's not arbitrary, and it must be the name of the module that you're testing. Okay? So far, so good? Any questions? Are we good? Let's keep going. So the first thing that I have is a function to create a whole bunch of fake profiles in the test drive. Okay? Now, I will be extremely honest and tell you that I did not start out this way. I had this code interspersed all through my tests, and when I began to repeat it, light goes on, okay, and I abstracted it and put it in this function, okay? So basically, I'm creating sort of fake profile paths. This switch parameter lets me select profiles in groups for testing. This is just a convenience. And then the real guts of it are down here, where I use the test drive variable, I use join path, and I use the test drive variable, which is the actual path to the test drive, with one of these profile drives, and then I use new item to create it, and if it fails, everything comes to a crashing halt. Okay? This is typically called an arrange block in testing. There's arrange, act, and assert, right? And this is the arrange. So there's my function. It's called new mocked profiles. Oh, one of the lessons I learned in this journey was one of the best ways to screw up your tests is to mismatch types, okay? So I'm very careful to be extremely explicit. If you try to compare an object of one type to an object of another type, you're going to get funny results. You get false positives and false negatives. So you have to be really careful that your types match. So here, this is returning a file info object, and I'm going to make sure that my commandlets are returning file info objects too, so that those two match. Again, that wasn't something I figured out on my first try. Okay? So let's go back to my help file. Are we doing okay on time? Yeah, we're good. Okay? And my first example in my get profile commandlet that isn't written yet is the command gets all profiles on the current system. So that's the tests that I want to write. So here's my describe block. And I always name mine for the function that I'm testing. That's just a custom. Okay? I've created a context block because I want to mock and I want to scope that mock. And you can see here that I use the name of the example in my context block. So it's example 1, mock with all profiles. And I actually use my mocking function with all profiles. And look what I'm mocking. I'm testing get profile, right? But I want to mock the input to it. So I'm going to dream up a get profile path helper function that get profile will call to get the paths to the profiles, because I don't want it to go to my real profiles, I want it to go to the test drive. And then get profile calls get profile path. I call get profile. I get a string out of it. I sort it, and I use should be like to create the test. Now, the reason that I do this enumeration, rather than just saying should be like something, is if you take an array and you pass it to should be like, the first time it gets a hit, it returns true, right? So if you have one of those that's right and all the others are wrong, you get a false positive, right? So you have to go through this enumeration, right? This is where inheriting from the PowerShell comparison operators gives Pester that unusual flair. This is supposed to be corrected in version 4 of Pester. Okay. So example 1 is that it gets all profiles, and I also, because I tend to be a little obsessive, tested to make sure that it gets only profiles. So I gave it some paths that were profile-like, created those, and made sure that I still only got 5. Okay. Now, I don't have any code, so when I run this, and I will run it, I'm going to restart the shell here. I never want to use test in a used session. Okay? I'm going to get an error. This isn't a real legitimate test error. This is just an exception because get profile path doesn't exist. Okay? So let's go to our next step. Here the tests are exactly like they were before, but I've written some code, and because it's me, I've written some help. Okay? So here's the little get profile path function. I made sure that it returns an array of strings, just like the mock that I did. Get profile calls get profile path, and then just gets the items in those paths. And that was all the code that was required to pass that test, nothing else. So when I run this in the console, now it passes. Okay? Questions? Okay, let's keep going. Okay. So the next thing I did that was sort of interesting, I'm going to skip over some of this in the interest of time and go to the disable profile commandlet, which is much more interesting than get. And example 1 is pretty easy. It gets profiles in the current user directory in $home, and it disables them. Great, everything works. Da-da. So for my test, easier. Okay. Let's close that function so that you can, so you can see it. Scroll down. Okay. So here's my test for disable profile. Here's example 1. It gets the current user profiles. I've mocked with current user. This time, the function that I'm mocking, because I'm testing disable profile, I want to mock anything that it calls that's a command in that module, because I want to isolate my tests for disable profile. If there's a problem in get profile, I don't want it to affect the result of my tests for disable profile. This is a unit test, and that's one of the best practices, okay? So I'm going to get a bunch of profiles. It's going to return those file info objects. I'm going to mock get profile. So when disable profile calls get profile won't run, and instead it will get file info objects on my test drive, okay? And then I'm going to do the same thing that I did before. I'm going to get strings, sort them, and use should be like. Okay? So that test wasn't really that hard to do. I was feeling pretty good about this. Then I hit example 2, okay? So example 2 was a behavioral decision that I had to make when I was designing the experience in my module, right? Some of those profiles are in the system32 directory. They're in PS home, right? And if I'm running in an unelevated session, I don't have permission to rename any files, okay? So I had to figure out, as the author of this module, what was going to happen in that scenario. And I decided that the best user experience, since I'm the primary user, is that I want to disable the profiles that I can and write a non-terminating error with write error for the profiles that I can't rename. Could have done it lots of different ways. So then I had to mock that up in testing or model that in testing. It wasn't all that easy. Okay, so here's example 2. I'm going to use all profiles in a non-admin session. So I created profiles on my test drive, one for each profile. I mocked get profile with the profiles. And then I created a little function called isAdmin, and I mocked it with false, right? And it just tests to see whether you're running in an elevated session. And I'm pretending that it's false because I'm testing in a non-elevated session, okay? So here's my test, here's my it block. I'm gonna run disable profile, and in order to test to make sure that it's gonna error out those system32 directories, I'm gonna use error action stop to convert that non-terminating error into a terminating error so that I can use Pester's should throw. There's no other way. If I were to let that non-terminating error go through the pipeline, it goes to the error stream. Pester looks at the output stream, I wouldn't see it. Okay? In order to use error action stop, which is one of the common parameters, I had to make disable profile an advanced function, meaning I had to add the command binding attribute or parameter attribute. Okay? The other thing to notice is that when you're piping input to should throw, the input always has to be enclosed in a script block. You'll get a lovely error if you don't do that. Okay? So here we go. So it will error out if it finds system32 profiles and you're not an admin. And before it errors out, it will actually go and disable any profiles in the home drive, in the current user profiles that are not in the system32 directory, and there should be 3 of those. And it does not disable the system32 profiles. Okay? So those were the 3 tests that I wrote for that case. Whoops. The other case is if I'm running in an admin session. Okay? In that case, I'm mocking isAdmin with true. I call disable profile, and this time it should not throw. Okay? And when I run, it will have disabled all 5 profiles. Okay? But I had to actually write that in 2 pieces, 2 context blocks. And the third example is what happens when there are no profiles. Okay? I decided that there's no output, there's no errors. So I go back into my code. Example 3, I mock get profile with null. When I run disable profile, I should not get anything back. I'm using error action stop again to convert that non-terminating error to a terminating error, and I use should not throw. Okay. In my module, I have that get profile path function. I have the isAdmin function. I also have a little can rename function that basically checks to see if the name includes system32 and you're not running as an admin, then you need to write an error. Sorry, I didn't show you the error. There you go. It returns true and false. Okay? And let's go look at disable profile. I use the commandlet binding attribute so I could use error action stop. And either it renames it or it writes the error. Okay? And now when I run this, and I'm going to clear that console first, restart the shell, run, oops, try it again, demos. Okay, run in console so you can see it. This is just RightHost, but you'll come to expect this sort of purple and green interface, right? Green is a passing test, red is a failing test, okay? And the test passed. I assure you that they did not pass the first time I did this, right? And it took a lot of manipulation with those output types and enumerations to make sure that I had tests that would fail and pass reliably. And the way I tested my tests was to change should to should not and should not to should and see if I could get them to pass and fail, right? Dave Wyatt famously said, if a test is not reliable if it will not fail. Okay, so I had to make sure that the tests failed and passed in a regular way, right, before I could rely on those. And I promise you, it never happened the first time. It's code, right? It took a lot of manipulation, and you can get into this regressive thing where you're testing your tests. Okay? So at this stage, I was kind of finished with my unit tests. I did the same thing for enable profile. And I began to worry that the fact that I was doing all this mocking and fooling around on the test drive made my tests less reliable than they could be. So I renamed the file from managedprofiles.test.ps1 to managedprofile.unittests. And I created a parallel integration test file for those same examples. Okay? Now, integration test, unlike a unit test, tests the commandlets in the module in coordination with each other in a real file system, right? So no mocking, okay? And I basically did another in module scope. Right now, it's just the original arrange function that created things on the test drive is gone. And there's no mocking here, I'm actually calling the commandlets. So I call get profile, nothing is mocked. Disable profile calls get profile. Okay, exactly like it was before. And what I'm doing here, let me move that cursor, in order to do the enumeration for the names I'm using just for each object and passing each one to should be like. Okay. I also, in order to test in an admin session, I put a pound requires run as administrator on this one, so I have to run this in an admin session, okay? So it mocks an admin session, it runs in an admin session and it tests for admin session artifacts. And now to run this one, I actually have to run in an admin session. So I'll open my console. I'll run Invoke Pester. I'll hold my breath. Ooh, error occurred in the test script. Let's go see what happened. Oh, I didn't run as admin. Demos. Sorry. Okay, invoke Pester. Run all of those tests. And now they should pass. The final thing that I did was to run a code coverage test. The code coverage parameter of Invoke Pester tells you which elements. Do you want me to open the window?
No, close the blinders.
To see the text.
Okay, great, thank you. Yeah. So the code coverage, let's go back here for just a sec. The code coverage parameter of Invoke Pester verifies that each line of the code is run at least once during the test. So it's a test for exercising the code. Okay? And I'm going to grab that folder path and run the tests. And I'm going to use, this time I'm going to type Invoke Pester. Okay. I'm going to use the code coverage parameter, and the value of the code coverage parameter is a path to the file that you want to test, and we want to test the module. You don't want to test your test file. Okay. And I'll show you the result. When the window shades are better than the demo. Okay.
Excuse me, we want those shades at the...
You guys, yes. Yeah, it looks like it's shining right in people's eyes. Yeah, thanks.
It's okay. Good enough. Good enough.
Okay, are we good? Okay. So the code coverage parameter does a code coverage test to make sure that every part of the code ran during the test. Now, apparently, I got a 97.5%, which for me is a failing grade. Okay. So I went back to figure out what was wrong, and it said that this thing on line 73, I had a warning that I wasn't testing for, or at least that's how I interpreted that, okay? And I thought, oh, that's true. I had a warning that reminded you that profiles are loaded when the session starts, so if you make a change to the profile, you need to restart your session to make the change effective, and I did not test that. I thought this was super clever, right? And it realized that I hadn't written a test for this. But let's go see what's really happening. It found the error or the code that wasn't exercised on line 173. This happened in real life. Make sure I have the version, yeah. I'm gonna go to line 173, and this is what happened. Here's my function. I cut and pasted some code from enable profile to disable profile, and I didn't paste it inside the final curly brace of enable profile. So what was happening here was that this code wasn't running at all. It wasn't that it wasn't tested, it's that it didn't run because it was outside of the function, okay? And I don't need to demo this for you because I rather use that time for some discussion. But when I put that if statement back in the function and run that code coverage test again, it passes even though there's still no test for this warning. Okay? So it's important to understand that that code coverage parameter verifies that the code is run, not that the code is tested. Okay? So here are my conclusions, and then I'll open this up for discussion. This took a long time, but it was the first tests I'd written. And the first scripts that I wrote took a long time too, okay? Over time, as I began to do this, and I have now written Pester tests for all of my production scripts, it became really easy because I learned how to write tests, I understood the comparison operators and how they worked, and I learned to reuse tests, right? I learned to develop tests that could be generalized. If I'm testing for names, I know how to do this. If I'm testing for errors, I know how to do this, okay? I wrote and shared on GitHub some tests to test in any module, whether it has basic help, right? The basic requirements for help. It will work in any module. Right? I never have to write that test again unless I want to make it more strict, okay? So it took a long time, but when I evaluate this process for the long term, it doesn't take very much time at all. Also because this one was very simple, right? You sort of have a basic amount of test code that you need to write. When you write it for a module that's very small and ridiculously simple, the ratio of test code to actual code is very high, but you write almost the same amount of test code for a module that's more complex, okay? And it doesn't take much more time. Another lesson is that it was much too easy to assume when I found a bug that it was a Pester bug. Okay? Pester is a project in development, right? And you can go and file issues on GitHub, right? And there were too many times when I just assumed that that couldn't be me, right? That this was a Pester bug. I did find a few. They were pretty minor. Most of the time, they were logic errors. Okay? So that was a mistake that I made. It was most valuable for regression testing, right? So my test is right, all of my my tests are fine, all of my code passes. I go to make a change in my code, and it's very easy to figure out if it actually changed the behavior. The output type, as we mentioned, is really valuable for tests and mocking, and I've actually begun to document errors in my help file, right, so that I can predict them and that users know what kind of errors they can expect when they run this, whether they're terminating errors that they need to put in a try-catch when they use it, or non-terminating errors where they need to use an if and error action, okay? And every module should have at least one test file. I put together a little glossary for you. You guys get all the slides, plus they're up on GitHub. And I put together a bunch of resources, including that great book by Kent Beck, who designed or introduced test-driven development. The examples in that book are in Java, but if you know PowerShell, you should be fine. Certainly if you know PowerShell classes. Okay? The slides and code for this are up on Pester in my Pester TDD directory, and I continue to update it. I owe a whole bunch of thanks to the Pester team and people who wrote those first articles in PowerShell magazine about Pester. I guess we all owe them a debt. And that was my real-world experience with test-driven development in Pester. So thank you. So let's talk. Outstanding issues. Yeah.
Thank you for the presentation. Wonderful.
Oh, thank you.
One question. There are three elements. There's Pester, there are the test scripts, and there are the PowerShell scripts. So what is happening behind the scenes if you test or if you let this code run?
Right. So the same thing happens when you use Invoke Pester or just run the code. Okay? Again, there's no magic that Pester does to associate a test file with a script file or module. In the test file, there needs to be code that either dot sources a script into the test or imports a module into the test scope, right? So Invoke Pester, the value of Invoke Pester is for its parameters, which do interesting things like selecting which tests you want to run by name or by tag, right? And generating real objects instead of just writing to the host, right? But it's that code at the top of your file that dot sources a script or imports a module that associates the test with the file that it's testing. Does that make sense? Yeah. So Pester still runs even when you don't run Invoke Pester. Okay? But Invoke Pester is a cool way to run things recursively. And when you're running as a job, right, or in a continuous integration system, which is what it's built for, that's exactly what you need. Yeah.
Well, actually, at least from what I've seen, they've intended this link between the test file with the test file name and the original script file.
Right.
When you run new fixture, it generates this link for you automatically.
Yeah, Sebastian, right? Okay. Yeah, so what he's saying is absolutely right. So there's a commandlet in Pester. That thing is in my eye. There's a commandlet in Pester called new fixture, and it's a great quick start commandlet. And it creates a test file and a script file for you, and they have the same base name, but one is .ps1 and the other one is .test.ps1. And there's a clunk of code at the top that figures out if I'm .test.ps1, I'm going to take .test, I'm going to figure out where I am at runtime using my invocation, my path, right? And I'm going to figure out the name of the actual file and slurp it in, okay? But that's the code that dot sources it into the script, right? But that's general code that will work for anything. Yeah, but good point. Thank you for doing that. But it is a custom to make sure to have the name of the test file match the name of the file being tested. And I think that's a smart thing to maintain, even if it's not a requirement. So yeah, thank you.
For compile commandlets, what is your recommendation? Going for custodial unit tests or going for Pester?
I can't answer that question. I'm not a developer. Does anyone have that kind of experience? I think for PowerShell stuff, you use Pester, right? I'm not sure Pester, like you can, if it's C# commandlets, you can use Pester. I don't know what's available in Visual Studio.
Yeah, in my experience, I've seen like the underlying API that you're writing in the classes, you would want to test that with Visual Studio Test or C# test.
So that would be the commandlet class that you're writing,
Right.
yeah.
Well, or like the helper classes that are working with the commandlet class, and then the overall PowerShell functionality, like parameters and things of that nature, you would test with Pester.
So the Visual Studio tests can test attributes of the commandlet class?
Well, like the underlying workings of
Right.
the
But so when I write a commandlet, I actually derive from the base class. So can it see inside my,
Right, so an example of power forensics would be you have Git forensic master boot record, right? Well, that's just implementing a public API that is written in C#, a public master boot
Right.
record class. That master boot record class would be tested in C#, as to where Git forensic master boot record, the commandlet, would be tested and tested.
Okay.
But
Oh, that's great.
You can also use PowerShell create and run spaces, and then add command to that.
Yeah, this is
execute that.
yeah. Then using unit tests just to test the command inside Visual Studio,
Right.
Yes.
and then this was I was asking best practices. What is the easier approach?
Yeah. Yeah.
I prefer to have all my tests in the same place. So
Visual Studio then.
Visual Studio, but then you end up in mixed commandlets where you write some commandlets in scripts and others in binaries, and then you're still in a mix.
Okay.
Right.
So,
Yeah, that looks like one of those things that needs a longer term solution. I think that what will happen is that the community will develop best practices over time. So, yeah. Any other questions? Yeah.
Does Pester provide mocking ability for .NET objects? Like not commandlets, like actual objects. Can you mock like a method on an object? Probably not. So.
I can't, you know, there's the it's not documented and the it can't do. So it's not documented.
Yeah.
I don't know if it can do it. And then there's also that you can't do it and Jared can't do it, right? So that, or I can't do it and Jared can't do it. There are some times when things can be done.
The easiest way to kind of work around that is to have like a factory function that creates a copy of that object with the method altered. So you just return a mock of the object from a mocked function or a helper function.
So you create an instance of the object and call the method on that instance.
Yeah, but that method's overridden, so it's not the original.
Right. So it's not actually testing that, yeah.
Yeah.
Kind of a icky. Since we have another just couple of seconds, I just want to draw your attention to some interesting things. So again, I pointed out that pretty purple and green and red stuff was RightHost. If you want to return a custom object that has all of the test results in it, you can use --pass-through. Okay, it still spills out the RightHost stuff, but it also writes out a PS custom object. The PS custom object has a single test results property value. The value of test property is an array. It's test results. The value of test results is an array of test results, one for each test. And you can use that the way you'd use any other PowerShell object. If you want to send that thing to a file, you use the output file and output format parameters, and it serializes it. It creates an XML file for you, and it uses XML schemas that are used by familiar kinds of reporting software, right? So it's all ready for reporting. And if you want to shut down the RightHost, don't do this. Say, don't spill all that out on my screen. I'm just using pass-through, or I'm sending it to an output file. You can use -quiet. -quiet will suppress the RightHost stuff, but it will also suppress the code coverage results. Sadly, I tried to do one or the other. Okay? Yeah, you can do all kinds of interesting things. You can pass a hash table to script, to the -script parameter, which takes the path to a test file. So by default, it runs every .test file that it can find, but you can specify a specific test file by path, by test name or tag. These both pertain only to the test name or tag of the describe block. This one supports wildcards. The tag, at least in version 3.4.0, does not support wildcards. So those are your filtering options. Okay? Anything else? Are we good? Thank you so much for coming.